Hey everybody, it's Mr. Hill. We are talking about parallel and perpendicular lines today. So we are writing equations of lines again, but we're writing equations of lines that are parallel or perpendicular to another line. Our answers today are all going to be in slope-intercept form, so we're back to y equals mx plus b, and we're not going to use point slope today. We will use that again in the future, but today we're just looking at y equals mx plus b. So first, what we have here is two parallel lines. And what we want to look at is how is their slope related. So if we look at the slope of this top line, if I start at 4, I'll go up 3. Sorry, that is not very good. We would go up 3 over 2. So the slope of this line is m equals 3 over 2. Now you look at a line that's parallel to that, this second line on the bottom, and you're going to notice that that one, I'm not doing a good job here. On that one, you are going to go up 3 also over 2. So the slope of this line is 3 over 2. So what that tells you is that parallel lines have the same slope. And we're going to use that relationship to find equations of other lines, or lines that are parallel to each other. So we're not going to find equations of these two lines right here. We're going to use this information. So this was just to show you visually that parallel lines are going to have the same slope. Different y-intercepts, but the same slope. So if we look at a problem that we're going to see, it's something like this. Find the equation of the line in slope-intercept form that goes through the point -3, -5, and is parallel to the following line. So what we want to do is just look at this. This line right here has a slope of 3. And the line that we're trying to find is parallel to this line. So what that tells you is that that line also has a slope of 3. But it's going to have a different y-intercept because it's parallel, but it's not the same line. So since it has a different y-intercept, we need to find that y-intercept. But again, notice we're using 3 because the lines are parallel. So what I'm going to do is use the point. This is x comma y, and I'm going to plug in. So we've done this before. -5 is y, 3 is the slope, -3 is the x value, and we're going to solve for b. So this is simple. -5 equals -9 plus b. I'm going to add 9 to each side, and I get 4 equals b, which means the answer is not b equals 4. The answer is y equals 3x plus 4. So most of this work we've done before. The only new thing is that we're given one line, and we're finding the equation of another line. In this case, parallel, we use the same slope. All right. Moving on to the next one. We have, these are perpendicular lines. That means they intersect at a 90-degree angle, right? That's what perpendicular means. So let's take a look at these. This first one here, I go up 2 over 3. You can see I'm a little bit off there, but if you count the boxes, you got 2 up over 3. So the slope of this is 2 over 3. One thing to notice about the other line is that, say I start right here at the y-intercept, I'm going to be going down, so it's definitely a negative slope, all right? In this case, I'm going to be going down 3 over 2. You know, it's not exact, but we're going to do the best we can. You know, so this one was up 2 over 3. This one was down 3 over 2. So here, 2, 3. This one down 3 over 2. So what happens here is this one is -3 over 2. So we want to look at how are these slopes related. And the way it works is we take the negative reciprocal. So we get 2 over 3. This one is -3 over 2. So we take the reciprocal and make it negative. If it is negative, we make it positive. And that's the relationship between perpendicular lines. So we're going to use that to solve something like this. Find the equation of the line in slope-intercept form, so make sure we're reading the directions. that goes through the point 4, -5 and perpendicular to the following line. So let's worry about the point later. Perpendicular. Well, we first need to find the slope of this line. Well, quite frankly, it's just 2 over 1 because it's y equals mx plus b, and m in this case is 2. It's easiest if we look at it as 2 over 1. Now, since the slope of this line is 2 over 1, we want to find the slope of the perpendicular line. So we're going to start a new line down here. And for m this time, we're going to take 2 over 1, we're going to flip it, and we're going to make it negative. If it was negative, we would make it positive. We have our x plus b. So this is the only step that's different. So to review, if this were a parallel line, we would use the slope 2 here. Since it's a perpendicular line, we're going to take 2 over 1 and make it -1 over 2. Now to solve for b, it's going to be just like the problem before, except this one's going through, if we can move up here, this one is going through the point 4, -5. So instead of y, I'm going to write -5, because that is the y value, and 4 is the x value. So we get -1/2 is the slope. We're going to put in 4 for the x value, and plus b. So this gives me -5 equals -1/2 times 4. Well, that's 4 times 1 is 4. 4 divided by 2 is 2. So we get -2 plus b. Solve for b, add 2 to both sides. -5 plus 2 is -3. Remember, solving for b is not your final answer. Your final answer is y equals -1/2 x minus 3. And that's all you have to do. Moving on. This is a quick slide. I'm just going to write these answers really quickly. This is just so we can recognize what the slope is. So I'm going to circle all the slopes of these lines. That's how you can quickly look at them, and that's what the slope is. The slope of the parallel line for number 1 would be 3. And the perpendicular line would be -1/3. That is because we take the reciprocal of 3 over 1 and we make it negative. For number 2, the slope is -1/2, so the parallel line would be -1/2. Parallel is going to be the same slope, and the negative reciprocal is 2 over 1, and it's positive. So if the parallel line is negative, the perpendicular line is positive. For number 3, very quickly, same exact slope. For the perpendicular, we're going to make it negative, and we're going to take the reciprocal. And for number 4, the last one, the slope is -2. And the perpendicular slope would be +1/2. Because remember, 2 is really 2 over 1. The reciprocal is 1 over 2. And I make it negative. And if it's already negative, I make it positive. So this is just a quick guide as far as what slope you're going to use. This isn't really solving any problems. This is just to give you a quick idea of which slope you would use. So again, parallel, you use the same slope. Perpendicular, the negative reciprocal. Moving on. Just a couple more problems. In this case, this is in standard form. So we can't just find the slope that easily. What we need to do is somehow solve for y so that it's in slope-intercept form. I'm going to do that by subtracting 2x from both sides. So I get -3y equals 9 minus 2x. And I'm going to divide each side by -3. And I'm going to get y equals, well, 9 divided by -3 is -3. And -2 divided by -3 is +2/3. And I have x. Well, another way to write that would be y equals 2/3 x minus 3. So it's in y equals mx plus b form, slope-intercept form. We locate the slope. So the slope is +2/3. So that means, and if I go back up and I look at this, this means we are looking here for the parallel line. So the parallel line means we use the same slope. So we use the slope y equals 2/3 x plus b. And now to find b, we're going to simply substitute a point. That point in this case is 6, -1. So I'm going to replace -1 for y 2/3 times 6 for x, -1. Well, 6 times 2/3 is 6 times 2, which is 12. 12 divided by 3 is 4, plus b. Subtract 4 from each side, and I'm going to get -5 equals b. So my final answer is y equals 2/3 x minus 5. Notice how similar it looks to this, because it has the same slope, but again, parallel lines have same slopes but different y-intercepts. Let's do one more similar to this. In this case, we're looking at perpendicular, so we've got to isolate y. So I'm going to subtract 4x from each side. So I get 10 minus 4x. Remember, 10 minus 4x, you can't combine those. They're not like terms. Then I'm going to divide by 3. So y equals 10, so I'm going to do this one over 3, minus this one is 4 over 3x. And if I write that in the correct order, it's -4/3 x plus 10 over 3. Then I go over here, and this time, notice the slope. The slope is -4/3, but the problem is telling me to do the perpendicular line to this line. So I'm going to flip it 3/4 and make it negative. Well, it's already negative, so that means a negative of a negative makes it positive. X plus b. And the last thing I need to do, solve for b. Let me go up really quickly. My point is -12, 7. So -12 is my x value, 7 is my y value. So 7 equals 3 over 4 times -12 plus b. If I multiply this out, let's try it a different way. Instead of multiplying first, let's divide. -12 divided by 4 is -3. Take that -3 and multiply by 3, and I get -9. So you could also do it that way. So I get 16 equals b. So I'm going to write my final answer. Again, it's common to just think you're done because you solved for b, but your final answer is 3/4 x plus 16. That's it for parallel and perpendicular if there's an x and a y. The last thing we have to talk about is if it's a special case. These are very, very easy if we understand it. So let's look at A. We're looking at the line that's parallel to this. Well, let's just do a quick graph of what this looks like. X equals 7 is a vertical line. Let's say the 7 is over here. Well, if we take a vertical line and we want to find a line that's parallel to that, a line that's parallel to a vertical line is just going to be another vertical line. So if I know it's a vertical line, my answer has to be x equals some number. Well, what number? Look at the point. So x has to equal -3. The special cases, as you've noticed, they're the least amount of work, but you just have to recognize when there's a special case. So now we look at part B. Part B is the perpendicular line, all right? Well, again, we're using the line x equals 7. So if we look at the red line that I drew here, that's a vertical line. Well, what type of line is going to be perpendicular to a vertical line? Let me just draw a line that's perpendicular. Well, that looks like a horizontal line. So since I know my answer for perpendicular is going to be horizontal, all it is y equals a number. What number? It's given at the point 4. So we don't have to solve anything for these. That's all we have to do. Actually, yes. Yeah, we're going to do one more of these and then we'll be done. All right, so similar. We know there's no x and y here. When there's just an x or just a y, that means it's a special case. In this case, it's y equals. Well, y equals -2 would be something like this. -2 is down here. And that's a horizontal line. So for part A, they want us to find the parallel line. Well, a line that's parallel to a horizontal line is going to be another horizontal line. So it's going to have the form y equals. And now we've got to find the y value. Well, it's just given in the problem at that specific point. So the answer is y equals -7. It's very simple. The other one is perpendicular. And just as an example, we are still using this horizontal line. Well, guess what type of line will be perpendicular to a horizontal line? It is a vertical line. So since I know the answer is a vertical line, I'm going to have x equals, and I need to figure out what number does x go through, and that's given in the specific point, so it's 2. So you just need to know that vertical lines are parallel to other vertical lines, horizontal lines are parallel to other horizontal lines, and horizontal and vertical lines are perpendicular to each other. So in these types of problems, you're not computing any slope or doing any negative reciprocals. You're simply just thinking about it and giving the answer. All right, so that's it for today. So make sure you come to class tomorrow and come with questions, and we will just work on this more tomorrow in class. Have a good night.